All right. So section 14.2 is on multiplying and dividing rational expressions. So you're multiplying and dividing rational expressions. Okay, so for example, let's look at number 10. Number 10. So the direction to say, it could say simplify, or it could say find the product. It could say find the product and simplify. Just know that it means all of those. So you have this rational expression. That's an x squared plus x divided by 8. So you have that rational expression. And a rational expression is a polynomial divided by a polynomial. But it's being multiplied by this rational expression. All right. So how many rational expressions do you see here? 2. Okay, to multiply these rational expressions, and the idea is to simplify as well, step 1 is to factor numerators and factor the denominators. That's step 1. So if you look at the numerators and if you look at the denominators, which ones can I factor? The first numerator. How do you factor x squared plus x? To be x times x plus 1. So I can't do anything else in terms of factoring. So step 1 is to factor. So everything else I'm going to leave alone. So step 1. Once you factor, then the next step is to reduce your common factors. Meaning this. What's the first factor that you see in the numerators as you go across? X. Does x occur as a factor anywhere in the denominators?
Yes. No.
No, not here. Don't say here because that's not x times 1. That's what? X plus 1. What's the next factor that you see?
X plus 1.
Does x plus 1 occur as a factor anywhere in the denominators? Yes. So remember, you can divide those out, meaning that when you do this, you're saying x plus 1 to x plus 1 is 1. X plus 1 to x plus 1 is 1. So you put the factors of 1s in their place. The next factor you see is what? 16. Does 16 reduce with anything in the denominator? The 8. 8 goes in 8 one time. 8 goes in 16 2 times. So step 1 was to factor. Step 2 was to reduce common factors. And then step 3 is to write as one rational expression. Rational expression. So, which meaning that you're either going to multiply, divide, whatever you're doing. So, if you look at when you multiply the numerators together, you have x times 1 times 2. What's that? 2x. In the denominator, that's 1 times 1, which is 1. But don't leave it like that, because we know that 2x divided by 1 is 2x. So there's your answer. So step 1 is to factor. Step 2 is to reduce your common factors. And then step 3 is to do the product division. Write as one fraction. All right, that was 16. I'm sorry, that was 10. Okay, let's look at 14. 14. Again, in order to be able to do these, you got to be able to do the previous chapter, which is factoring, and you have to know how to simplify rational expressions, which was the previous lesson. Okay, here's 14. You have a squared minus 4a plus 4 divided by a squared minus 4 times a plus 3 divided by a minus 2. So how many rational expressions do you see? What are you doing to those two rational expressions? Multiplying, right? Multiply. What's step 1? Factor. So can I factor that numerator? The first numerator? Yes. Right, so you got to remember how to factor. So at this point, I'm hoping that you're more quicker at factoring. What is that factoring? No, a minus 2 times a minus 2. A minus 2 times a minus 2. What about the denominator? What is that? That's the difference of 2 squares. How do you factor that? A plus 2. A minus 2 times a plus 2. Can I factor that numerator in the second rational expression? No. Can I factor the denominator in that second rational expression? No. All right, so that's where I'm at. So did I do step 1? Yes. Okay. Now what's step 2? Reduce. So step 2 is to reduce. What's the first factor listed? A minus 2. Will that reduce with anything in the denominator? Yes. When I cross them out, what do I put in their places? Ones. Factors of ones. All right. Did you pick up the worksheets that are due?
Yeah.
Okay. What's the next factor that you see? A minus 2. Will that reduce with anything in the denominator? Yeah. I can reduce these, right? Now, when I first did this one, I reduced this one and this one. Could I have done these two instead? Yeah. What's the next factor that you see? Will that reduce anything down there? No. So you're done. You just write one fraction. 1 times a plus 3 is what? A plus 3. 1 times a plus 2 times 1 is what? There's your answer. So a plus 3 divided by a plus 2. That's all it is. Very simple. In order to be able to do this, you got to be able to know how to do a lot of what we did before. Factoring and the previous section, 14.1. Okay, let's look at 34. 34. We have 3x squared plus 12x divided by 6 times, that's next, times 9 divided by 2x plus 8. All right. What's the first step? Factor. The first numerator, can I factor? Yes. How do I factor that?
3x.
Is the GCF, right? So the first numerator is going to be 3x times what? Plus 4. The denominator is just a number, so I'm going to rewrite it. The numerator over here is just a number, I'm just going to rewrite it. It's just a monomial, so I'm just going to rewrite it. The denominator, though, in the second fraction is a binomial. Can I factor that one? What can I factor out? 2. So that's 2 times what? 4. Okay, so that's where I'm at. Okay? All right, now, what's step 2? Reduce. Okay, what is the first factor listed in the numerator? Don't say 3x, it's actually what? 3. 3, right? Okay, because it's 3 times x plus 4. So there's 3 factors, a 3, an x plus 4. So you got to look at it as a 3, though, not a 3x, as a 3. Will that 3 reduce with any number down there? With any factor down there? A 6. So 3 to 3 is 1, 3 to 6 is what? 2. Okay? What is the next factor that you see? X. Will x reduce with the factor down there? No. What's the next factor that you see? Will that reduce with anything down there?
Yes.
The next one's 4. So when I reduce them, I'm left with 1s in their place. What's the next factor that you see in the numerators? 9. Will 9 reduce with anything down there? No. So all you do now is write as one fraction. So now you're on step 3. 1 times x times 1 times 9 is 9x. 2 times 2 times 1 is 4. So there's your answer. So 9/4 x or 9x divided by 4. It does not matter how you write it. So you can say 9x divided by 4, or you can say 9/4 x. Okay? 38. You have x squared minus y squared divided by 3x squared plus 3xy times, over here, you have 3x squared plus 6x divided by 3x squared minus 2xy minus y squared. That's a y. So x squared minus y squared divided by 3x squared plus 3xy, that's that first rational expression. The second one is 3x squared plus 6x divided by that trinomial, which is 3x squared minus 2xy minus y squared. All right, what's the first step? Factors. So remember, you can only reduce factors. All right, so how do I factor that first numerator? What is that? Difference of two squares. Two squares. How do you factor difference of two squares in this case? Yep. What about the denominator? How do I factor that? GCF is 3x. So that's going to be 3x times what? X plus y, okay. How do I factor the numerator, that second rational expression? 3x again, times what? X plus 2. All right, now let's factor that trinomial. The GCF is 1, right? So we go to the two binomials. What do you think is going to work? 3x and x, right? And the y squared is only one possibility, y and y. Last sign's negative. Signs have to be different. So which one's going to be plus, which one's going to be minus? 3x plus y, and then what? X minus y. That's the one that works. Okay. So again, in order to be able to do these, and from now on, everything we do from now on involves factoring and being able to remember they all connect the previous lessons. What's the first? Now we reduce. We do step 2. What's the first factor that you see? Do you see any of those in the denominator?
Yes.
Yes. So when I reduce them, I'm left with factors of 1 in their place. Because it makes sense, because x minus y divided by x minus y is 1, right? So you put 1s in their place. What's the next factor that you see? There's 1 right underneath. So that's just 1. The next factor you see is a 3. Not a 3x, a 3. I'm just saying, what's the next factor that you see? 3. Is there 3 occurring in the denominator anywhere?
Yes.
As a factor. It's occurring here, but is that 3 a factor? This whole thing is one factor right here. But 3 is here, right? So 1, 1. The next factor you see is what? Do you see an x as a factor? This one here. The next factor you see is x plus 2. Do you see it anywhere in the denominator? So then you write your final answer. 1 times 1 times 1 times 1 times x plus 2 is x plus 2. Denominator. 1 times 1 times 1 times 3x plus y times 1 is 3x plus y. So there's your answer. It's not difficult. Okay? All right, now, let's look at number okay, so this is going to be number 2. Number 2. You have 9x squared divided by y times 4y divided by 3x cubed. So again, you're multiplying two rational expressions. Now remember, step 1 says to factor. But if you look at all the numerators and if you look at all the denominators, those are monomials. You agree that this is a monomial, this is a monomial. Monomial mean one term. Since those are monomials, there's nothing you can factor. Okay? So can I do step 1? No. Step 2 is to reduce. Can I reduce? Yes. What's the first factor that you see? 9. Well, 9 reduced with a factor in the denominator. The 3. Okay, now, remember, don't cross them out, put ones in their place, because you know that's not true. You got to say this, 3 into 3 is 1, 3 into 9 is 3. Okay, that is a 1, that is a what? 3. Okay. All right, now, what's the next factor you see? X. It occurs a factor how many times? 2. Okay? Does x occur as a factor anywhere in the denominator? Yes. How many times? 3. All right, so I want you to think about this. In your mind, this is what you have. This is the best way to do this. In your mind, this is what you have. X times x. X right means x times x, right? Okay. The denominator, x cubed, means x times x times x. You agree? Yes. And then reduce. Just like this. You see what I did? What's the numerator? 1. What's the denominator? X. All right, now here's how you're going to do this. So that means that all this becomes what factor? 1. All this becomes what factor? X. Okay, very good. Okay, so it's best if you do those like we just did. Okay? All right, now let's go to the next factor. Next factor you see is 4. Can I reduce from 4 to any factor in the denominator? No. The next factor you see is y. And there's just 1, right? Can that reduce with anything in the denominator? Yes, in fact, there's just 1 as well. So that means that when I reduce those, what factors I put in their place? 1. See what I did? And then you're done with step 2. Step 3 is to raise one fraction. 3 times 1 times 4 times 1 is 12. That's my numerator. My denominator. 1 times 1 times x is x. So 12 divided by x. Okay? All right, let's look at another one like that. So this is going to be number 4. Let's look at number 4. Okay, you have 6x squared divided by 10x cubed times 5x divided by 12. So we're going to do this in a couple of ways, but let's kind of start this one like we did the previous one. Can I factor anything? No. No, because they're all monomials.
Right.
You don't have a binomial, you don't have a trinomial. That's when we see those, that's what we factor. Those are all monomials. So now I'm done with step one. Step two is to reduce. What's the first factor that you see?
6.
X. Will that reduce with anything in the denominator?
Yes.
In fact, two things. I can reduce the 6 with a 10, couldn't I? Or I could reduce the 6 with a what? 12. Which one do you want to do? It does not matter. 12? 6 into 6 is 1. 6 into 12 is 2. Okay, so that's where I'm at. The next factor is x. But it occurs how many times? Twice. So I'm going to think of it this way. Can that reduce with anything on there? Do I have any x occurrence of factors in the denominator?
Yes.
Yes, in fact, right here and there, how many of them? And now let's kind of reduce this. So x into x into x, and that's all, right? So that's going to be a 1 up here, and that's going to be a what? An x. So that means this. That means that this x squared becomes what factor? And this x cubed becomes what factor? X. So that's where I'm at. Okay? What's the next factor you see? Will that reduce with anything in the denominator? The 10. 5 and 5 is 1. 5 and 10 is 2. So there's a lot of crossing out here. It becomes a little bit messy, so don't make it too messy. What's the next factor you see? Does x occur anywhere in the denominator? Yes. Right here. So that's a 1 and that's a what? 1. And I'm done with my numerators. So I'm done with step 2. Step 3 is to multiply, rise one fraction. Let's do the numerator. 1 times 1 times 1 times 1 is 1. The denominators. 2 times 1 times 2 is 4. So the answer is 1/4. Okay? All right, now I'm going to rewrite this over. I'm going to just round the problem over. So, since those are just monomials, probably the best way to have done that was what we did. But I just want to show you something. Since all we have are monomials, I can do step 3 first, which means to multiply and rise one fraction. So what's 6 times 5? 30. What's x squared times x? X cubed. Good, because remember last semester when you multiply like bases, you add exponents. So x squared times x is x to the 3rd power. So that's the numerator. The denominator, let's multiply those out. What's 10 times 2? And so I'm just left with 20 what? X cubed. Well, what now? Oh, 12. I'm sorry. Thank you. So that's 120, right? Okay. All right. Okay, now let's reduce. Let's go back to step 1. 30 is my first factor. Does 30 reduce anything in the denominator? 120. 30 is 1. 30 120 is 4. The next factor you see is an x. How many of those do you see? 3. Will that reduce anything on there? Yeah, in fact, it's the same amount, right? So when I cross those out, I'm left with what in their place? And you're done. What's the answer? 1/4. Okay? Yeah, it depends. If all you have are monomials, there are a couple of ways you could do that. Depending on what you want to do. It does not matter to me what you do first. So, for example, when you look at the one we just did right here, so you could have written this. I'm gonna go back here. So you could have written this as one fraction first, What's 9 times 4? 36. What's x squared times y? X squared y. Okay, you agree that would be the numerator? The denominator, you have y times 3 times x cubed, which would just be 3x cubed y, right? Okay, and now let's reduce. 36 reduces to 3. 3 to 3 is 1. 3 to 36 is 12. Okay, next factor is x. There are 2 here, 3 down here. So that means when I cross those out, what's up here, though? What's down here? X. And the y is the same amount. So when I cross them out, when I divide them out, I'm left with factors of 1. And so therefore your answer is 12 times 1 times 1, which is 12. 1 times x times 1 is x. So it does not matter what approach you take. It's up to you. Okay? All right. Now, when you do number 6, though, when you look at number 6, you have this. You have negative 9x cubed y squared divided by 18x y to the 5th times y cubed. Looks just like this. Okay, so I'm still multiplying two rational expressions. Y cubed is a rational expression. But I can also write y cubed as y cubed divided by 1. If you need to do it that way, that's fine. So in other words, you can write this as this. Right? Okay, now, this may be easier to do if you multiply first. You want to multiply first? So 9 times x cubed times y squared times y cubed is what? Y to the 5th. When you multiply like bases, we do those exponents. You add them. But don't forget there's a negative out here. Divided by, and then what's 18x y to the 5th times 1? 18x y to the 5th, right? See how easy this is now? Now, what's the first factor you see in the numerator? 9. Well, the negative's out in front. The negative's out in front of that fraction. Now, you can't rewrite it as negative 9. You can put the negative in the numerator, but they have it written in front. But it doesn't matter. Okay, you can, if you want to, instead of putting the negative out here, you can just say negative 9. Does not matter. I'm going to leave it out there, though. 9 to 9 is 1. 9 to 18 is 2. All right, let's talk about the factor of x in the numerator. How many are there? 3. How many are there in the denominator?
1.
Okay. So when you reduce, what's going to go in the numerator? X squared. Because really, if you think about what you have is this. You have x cubed in the numerator, right? That's really x times x times x. Y'all agree? How many factors of x do you see down there? All right, now let's reduce. 1, 1. And then the numerator becomes 1 times x, which is x squared over what? 1. Okay. So when you cross this out, this really becomes what? X squared, and this becomes 1. Okay. What do you notice about the factors of y's? They're the same. So when those reduce, you're left with what factors? 1. And you're almost done. What's the answer? No, okay, negative x squared, just like this, over what? 2, like that, where the negative's out in front. Or if you want to, couldn't you have said negative x squared over 2 like that? All right. Now, just be careful, though. See how I wrote it like this? It looks like negative x is being squared, right? But you know mathematically from your experiences in previous courses that what is actually being squared? X only. And whatever that is, that's going to be what? Negative. All right, so that was number 6. So it's not that difficult. Fairly simple to do. Let's look at 28 now. So 28 is going to involve something that we've talked about. That was in one of the worksheets. So let's see if you remember 28. All right, did you pick up the worksheets that are due? They're right here. Okay, no. You didn't pick up, you need, okay. So get one of each. Here's the two worksheets. Okay, so number 28 is this. So you have x minus 3 divided by 2 minus x. Oops, sorry. That's a division. Okay. All right, so I'm going to come back to that one. So 28 is division, so I don't want to do that one yet. Let me see if I can, there's not one like this in here. Let's see if I can find it. All right, so that's fine. Let's do this one. So I'm writing this example. Example. X squared minus 4 divided by 24x times 6xy divided by 2 minus x. Just write this example. Okay.
24x.
2 minus x. 24x. 24x. Yes. 24x. Okay. Can I do step 1? Can I factor anything?
Yes.
Yes. The first numerator I can factor. That's a binomial, and it's the difference of two squares. So how do you factor that one? All right. The denominator is a monomial. Leave it alone. 24x. Now let's go to the second fraction, the second rational expression. The numerator is a monomial. Leave it alone. Now this binomial, can I factor that one? No. 2 minus x. All right, so that's where I'm at. Okay. Now let's do step 2. The first factor you see is x plus 2. Well, x plus 2 occurs a factor anywhere in the denominator.
Yes.
Where?
No.
No. There's no x plus 2 as a factor in the denominator. Right?
Right.
Okay. The next factor is x minus 2. Do you see x minus 2 in the denominator?
Yes.
Okay. The answer is no. You don't see x minus 2 exactly, right? But you do know that its opposite appears in the denominator. Right? So remember on the previous lesson what you did, you crossed these out, you divided these out, because remember when you divide opposites, what's their quotient equal to? -1, good. So I'm going to put the -1 in the numerator, I'm going to put the 1 in the denominator. Okay? All right, so you can now look at opposites. The next factor you see is 6. Does 6 reduce anything in the denominator?
Yes. Yes.
24. 6 and 6 is 1. 6 and 24 is 4. The next factor you see is what? X. Does that reduce in the denominator? Yes. In fact, you have the same number. So they divide out and become factors of 1s. What's the next factor that you see?
1.
Does it occur anywhere in the denominator?
No.
No. So that's step 2. Step 3 is to write as one fraction. So you have x plus 2 times a negative 1 times 1 times 1 times y. All right, now let me tell you how to write this. We tend to put the binomial factors in front of the binomial. Okay? So in other words, instead of saying x plus 2 times a negative y, you want to write as what? Negative y times what? X plus 2. And leave it in parentheses, the x plus 2. Don't distribute. Leave it alone. Leave them in factored form. Okay? But make sure you put the monomial factor in front. The denominator, though, is just what? 4. So all that divided by 4. Now, this looks like a 4, but that's a y. The denominator is a 4. So there's your answer. That's how you do. Okay? Now, let's kind of redo something about division. So if you had this, if you had 3/5 divided by 2/3. Now this is from Math 97. What did you do to divide these two fractions? You change it to what kind of problem? Multiplication. So you said 3/5 times what? 3/2, and then you would reduce and then multiply. So you cannot reduce, so the answer would be 9/10. All right. Now, knowing that when you have a division, you're going to change it to what? Multiplication. Let's look at this now. So this is going to be number 40. This is number 40. You have x plus 3 divided by x squared minus 9 divided by 5x plus 15 divided by x minus 3 squared. All right, so x plus 3 divided by x squared minus 9 divided by, so that rational expression being divided by this rational expression, which is 5x plus 15 divided by x minus 3 squared. All right, so now we're not multiplying, but we're what? Dividing. So when we had written step 1 was to factor, step 2 was to reduce. In this case, step 1 is to first change it to a multiplication problem. So step 1, change to multiplication. Rewrite as a multiplication. All right, so in other words, just like we did that review, the first rational expression stays as it is. X plus 3 divided by x squared minus 9. And then you say times what though? X minus 3 squared divided by 5x plus 15. So that was step 1. So it's just like multiplication, except you just have an additional step, and the additional step is the first thing you're going to do. Change the multiplication problem. And now the rest is just like you did before. Step 2 then becomes factor. Can I factor anything in the numerators? But it's already factored, right? It's just written as x minus 3 squared. Now, if you want to, you can write as x minus 3 times x minus 3. There's nothing wrong with that. In fact, you may want to do that. You may want to rewrite x minus 3 squared as x minus 3 times x minus 3, but it's already factored. Can I factor this denominator? Yeah, so I'm going to go ahead and rewrite this. I'm going to go ahead and say x plus 3 divided by, and that's going to be x minus 3 times x plus 3, the difference of 2 squares. And if you want to, you can go ahead and write this as x minus 3 times x minus 3. How do you factor the denominator? 5 times x plus 3. All right, so that's where I'm at. So that was step 2. Once you do the factoring, what's the next step? Reduce. So step 3 is to reduce. Okay, what's the first factor that you see in the numerator? Does that occur as a factor in the denominator? Yeah, in fact, 2 times, right? Doesn't matter which one I use. No, does not matter. You want to use this one? Okay, when I reduce them, what factors are left? Ones. What's the next factor you see? Does it occur as a factor in the denominator? Yes, so I can reduce that. What's the next factor that you see? Do you have one in the denominator? No. So now we can do step 4, which is to write as one rational expression. So what's going to be the numerator? X minus 3. What's the denominator? Yeah, don't distribute. Leave them in factored form. Okay, so I'm going to write it down. Leave in factored form. So don't say x minus 3 divided by 5x plus 15. Leave it as 5 times what? X plus 3. And there's your answer. That's how we write it. We write it in factored form. We leave the answer in factored form. Okay? So leave the answer in factored form. Don't distribute. Actually, that's 40. So it's just like we've been doing, except with division, you just do that extra step first, and that's to change it to multiplication. So let's do a couple with division, and then that'll be it, because you already know how to multiply. So let's look at, that was number 40. So let's do number 30. Number 30. So here's 30. All right, so 30, you have x plus 1 divided by 2x squared plus 5x plus 3. So that rational expression is being divided by this one, 20x plus 100 divided by 2x plus 3. 20x plus 100. That's the 20. All right. What's step 1? Change the multiplication. So x plus 1 divided by 2x squared plus 5x plus 3 times what? Over? Right. Okay. So that was step 1. So step 1 was to change the division multiplication. And once you change multiplication, it's very easy after that. What's the next step? Factor. Can I factor x plus 1? No. Can I factor the denominator? Yes. The GCF is 1 in the denominator, so you're going to do the 2 binomials. So do y'all agree that's going to be 2x, x, 3 and 1, so I'm going to need the 3 here and the 1 here. And they're both what signs? Addition. All right, so that's that one. Okay, can I factor the numerator of the second rational expression? No. Can I factor the denominator of the second rational expression? Yes. GCF is 20. 20 times what? X plus 5, right? Okay, so that's where I'm at. So we got a factor. So make sure you factor. First factor is x plus 1. Will that reduce it to any factors in the denominator?
Yes.
Yes. So when those divide out, I'm left 1 to their place. The next factor is 2x plus 3. Does that occur anywhere in the denominator? Yes. And that's all I can do. Now let's write the answer. 1 times 1 is 1. 1 times 1 times 20 times x plus 5 is 20 times x plus 5. There's your answer. Leave it in factored form. right, 48. 48. And it's not that difficult. All right, 48, you have 36n squared minus 64 divided by 3n squared minus 10n plus 8 divided by 3n squared minus 5n minus 12 divided by n squared minus 9n plus 14. Okay. Step 1.
Making a multiplication.
Change the multiplication problem. So I have 36n squared minus 64 divided by 3n squared minus 10n plus 8 times. And then I multiply by the reciprocal. So the reciprocal is going to be n squared minus 9n plus 14. 3n squared minus 5n minus 12. Okay, so all I did was just change the multiplication. That was it. Now, what's the next step? Factor. Okay, let's look at the first numerator. How do you factor that?
6e minus 8.
Okay, so you want to, so you see it's the difference of two squares?
Yeah.
All right, so some of you are saying 6n minus 8 times 6n plus 8. Okay, now, you can leave it like that, but in the end, you're going to see you have to do something else. You remember, there's a GCF in that one.
Yeah.
You either do it now or you do it later. So the GCF is 4, right? GCF is 4. So
Let's go with the first way and see what we have to do at the end.
I'll do both ways.
Okay.
So the GCF is 4. So it'll be 4 times what? 9 n squared minus 16, right? Over, now let's factor this denominator. So the denominator, GCF is 1, so I'm going to factor 2 binomials. So 3n, n, all right, 8, I can use 8, 1, 4, 2. The one that's going to work will be 4 and 2. It turns out that the 4 has to go here, the 2 has to go here. The last sign's positive, means both of these signs are the same. Nope, wrong one. I put them in the wrong place. The 4 has to go here. The 2 has to go here. Sorry. 4 here, 2 here. Last sign's positive, means these signs are the same. They're both what? Now let's check though. What's the outer? Negative 6n. The inner is a negative 4n. When I add them up, do I get the negative 10n? Yes. So I wrote it correctly. Times, all right, the numerator here, GCF is 1, so I'm going directly to 2 binomials. N, what do you think is going to work? 7 and 2, both negative. Good. The denominator, GCF is 1, 2 binomials, 3n, n. Now let's think about 12. 4, 3, 6, 2, 12, 1. 3, 4. So you know that if you use 3, 4, you know that 3 can go here. Because that means you could factor out a 3. So the 3 has to go here, the 4 has to go here. Now let's check this before we go on. The outer is 9. The inner is 4n, right? Now, notice the last sign's negative, so that means I'm going to have to subtract those. When I subtract 4 from 9, I get what? 5, which is what I wanted. I wanted a 5, right? But I really want a negative 5 in. So the order's correct. I just got to put the signs in the correct place. 4 is going to be a plus, and 3 is going to be a negative. All right, now, the 9n squared minus 16, I can do something else with that. So I'm going to go ahead and factor it up here. So that's going to be what? I'm factoring it right here. 3n minus 4 times 3n plus 4. I didn't have enough room to rewrite it, so I just factored it right above it. Okay, so did I complete step 2, which is factoring?
Yes.
Yes. Okay, now let's reduce. First factor you see is a 4. Will 4 reduce at any factor down there? No. The next factor you see is 3n minus 4.
Yes.
Yes. This one here, right?
Yeah.
So I'm going to cross these out, divide those out, one's in their place, factors of 1. The next factor you see is there 3n plus 4 down there?
Yes.
Yes. Divide those out, factors of 1 in their place. The next factor you see is there 1 down there? No. Next factor you see is there 1 down there? Yes. So I'm done. You just write as one fraction. 4 times 1 times 1 times n minus 7 times 1 is 4 times n minus 7. That's your numerator. The denominator, 1 times 1 times 1 times n minus 3 is n minus 3. So there's your answer. Okay? All right, now, if you had not done the GCF first, here's what you would have had to do. All right, so you would have, okay, so this is number 48 again. I'm putting a little star here. So I'm going directly from this step to here. So I'm assuming you've already done the change, division, multiplication. So what someone wanted to do was say 6n minus 8 times 6n plus 8, right? The denominator would have become 3n minus 4 times n minus 4. Over here, the numerator was what? N minus 7, n minus 2. And the denominator was 3n plus 4 times n minus 3. So I skipped a lot of steps here because I didn't want to redo this whole thing over. The only difference was that person would have had this instead. Okay, so then what would have happened was this. You would have said, all right, my first factor is 6n minus 8, right? Is there a 6n minus 8 occurs as a factor down there? No. The next factor is 6n plus 8 rather. There's not a 6n plus 8 in the denominator. That's your thought process. The next one is n minus 7. There's no n minus 7 as a factor down there. And the n minus 2, there's none. So you might say, well, there's nothing you can do. Well, yes, there is, because you didn't factor completely. What do you notice about this right here? So I can factor out a 2. So it's 2 times what? 3n minus 4. What's here? 2. So that's 2 times what? 3n plus 4. And then you reduce. So you would say, all right, the first factor is a 2. Would 2 reduce anything on there? Next factor is 3n minus 4. Will that reduce anything on there? Yes. Next factor you see is a 2. Will 2 reduce anything down there? Next factor is 3n plus 4. Will that reduce? Yes. Next factor is n minus 7. No? Did I miss something here?
Yeah, I thought it.
Oh, that should be n minus 2. I'm sorry. Because remember, I said 4 and then I messed that up. Okay, n minus 2. Next factor is n minus 7. Will n minus 7 reduce? No. N minus 2 will, though, right? And so then your answer would be 2 times 1 times 2 times 1 times n minus 7 times 1 is 4 times n minus 7. 1 times 1 times 1 times n minus 3 is n minus 3. So that's what you have to do. Okay? It's always best to do the GCF at the beginning. That's 48. All right, let's look at 18. You have 9y to the 4th divided by 6y divided by y squared divided by 3. First thing you do, multiplication, right? 9y to the 4th divided by 6y times what? Yep. And then remember, that's the next part would be one or two approaches you want to take. It might be easier for some of you just to multiply first and then reduce, because all you see here are monomials, right?
Right.
So the question I would ask is, can you factor anything? No. They're all monomial factors. So what's the next step? You can either reduce first and then multiply, or you can multiply first and then do what? Reduce. What do you want to do? Reduce first? Okay. Here's what you have to do, though. It's kind of a little bit more work to reduce first. So you're going to say first factor is 9. Will 9 reduce anything under there? Yes, the 6. 3 into 6 is 2. 3 to 9 is 3. Next factor is is y. How many factors do you see? 4. Will that reduce anything on there?
Yes.
Yes, there's 1 here, there's 2 there. Which one do you want to do? The 2. Okay. So remember what happens. You have y times y times y times y, right? Denominator y times y. We said 2 here. These divide out. These divide out. What's left? Over what? 1. So that means this. That means this becomes what? Y squared. This becomes what? 1. I still have a factor y here. How many do you have? 2. How many do you have down here? 1. So I have y squared. Oops. Y times y over what? Y. Those divide out 1. What are you left with? Over 1. So that means I can reduce that. That becomes a y, and that becomes a what? 1. See, it becomes a little bit messy now. Next factor you see is a 3. Can I reduce that? No. So here's what I have. 3 times this is what? Y times 3 is 9y over 2 times 1 is 2. It became messy. It would have been easier, I think, if you would have gone from here to, not here, I'm sorry, going from here to the product first. What is 9y to the 4th times 3? 27 y to the 4th. What is 6 times y squared? Cubed. It becomes easier that way. Can I reduce 27 and 6? Yes. They're both divisible by 3. 3 into 6 is 2. 3 into 27 is 9. See the 9 halves? How many factors of y do you have in the numerator? 4. How many factors of y do you have in the denominator? 3. Reduce. You have ones in their places. So it's the only thing left in the numerator. Denominator. So that becomes y. That becomes what? And now your answer is just 9y over 2. So it's easier sometimes just to multiply first and then reduce if all you have are monomials. Okay? All right, so that's all this section was about. That's all this was. So when you look at the worksheets that go with this, so this is 14.2. So 14.2 part A is this. All right, so that's it. So you have monomials. Now you're starting to have binomials. So you would factor here. Same thing here. So this part deals with multiplication. So when you do the monomials, you may want to multiply first and then reduce. But just say show work, okay? Show work. Back page, multiplication. 1, you see right here, the 4 minus x? there's going to be an x minus 4. So that means those are what? Opposites. Opposites. So remember the opposites. Negative 1, 1. Okay, so that's part A. So part A dealt with multiplication. Part B deals with division. So step 1 is going to always be what? Change to multiplication. Okay? And then when change to multiplication becomes like part A. All right, any questions? So there's only 2 worksheets on 14.2. 14.2. Okay? All right, now. Okay. So what we're going to do next, and I need to give your test back, so we can't start. But the next class period, Tuesday, we're going to look at, so with these rational expressions, we multiply and divide it, right? What else can you do to fractions? Not only can you multiply and divide them, you can do what? Add and subtract. So the next thing we're going to do is add and subtract. Now remember, when you add and subtracted fractions, your denominators had to be the same. So we're going to learn how to get the same denominators with polynomials. Okay? But in order to be able to do this, you have to know how to factor. You have to know how to factor. If you don't know how to factor, you're going to be struggling with these. Okay. So I'm going to